Hello students, you are welcome to Pokuare e-learning platform. We are going to study physics and the topic for today is magnetism. This is our first lesson. Your facilitator is Francis Nkrumah. Learning objectives. By the end of the lesson, students should be able to 1. Describe the causes of magnetism. 2. Define magnetic domain. 3. Explain types of magnets. 4. Explain at least 5 properties of magnets. 5. Define magnetic field. 6. Describe an experiment on how to plot magnetic field lines. Magnetism. Magnetism is the study of magnets, their properties, behaviors, and their interaction with other objects. Magnetism is described as an attractive and repulsive phenomenon produced by a moving electric charge or electron. A body possessing the property of magnetism is called a magnet. A magnet can also be defined as a piece of metal which can attract certain materials. Causes of magnetism. Movement of charges produces magnetic field or magnets. Moving charges produce magnetic fields. Let's just look at this demonstration. Let us pass a current through the solenoid and observe the pattern of the magnetic field lines. The magnetic field lines are seen as a bar magnet. They pass through the solenoid and return at the other end. The field lines are parallel to each other. So this is one of the means by which magnetism is produced. The second cause is electronic motions, spin and orbital. Magnetic properties of a substance are attributed to the electronic motions, orbital and spin in the atoms of the substance. Due to these motions, each atom is equivalent to a tiny current loop and produces magnetic field. And the magnetic field will be produced if these electrons are made to move in the same or to spin in the same directions. When a substance is magnetized by some process, all current loops are aligned with their planes parallel to one another and current circulating in the same direction. Hence, resultant magnetic field is produced. Magnetic dipole. Each of the above regions represents a group of electrons that are in a specific direction. Each group in a region has its own direction, and they are a group of electrons exhibiting the same characteristics, or they have aligned themselves in a specific direction. If these electrons are influenced by external field, they align themselves in a specific direction. Example, using a DC source. If these domains are also influenced using alternating current source, they may also be rotating or changing their directions as that of the alternating current. And this is what you talk about the magnetic domain. We have two diagrams here. The diagrams on the left represent domains of unmagnetized material. For domains of unmagnetized material, they are pointing in different directions and their magnitude cancel each other. But when you look at the ones on the right side, the domains of the magnetized material, you see that all of them are pointing in the same direction. And this, we are talking about the domains of magnetized material. Magnetic domain definition. It is a region in which the magnetic fields of atoms are grouped together and aligned in one direction. I take it again. It is a region in which the magnetic fields of atoms are grouped together and aligned in one direction. In a magnetized object, all the magnetic domains are pointing in different directions. When the metal becomes magnetized, all like magnetic poles line up and pointed in the same direction. Types of magnets. Magnets are grouped under two main categories. Category 1, we have natural magnets and artificial magnets. And we have another category, category 2, permanent magnets and temporal magnets. Natural magnets. A natural magnet is an ore of iron, which 1 attracts small pieces of iron, cobalt, and nickel towards it. 2, when suspended freely, comes to rest along north-south direction. Examples are magnetite, F, etc. They are irregular in shape and not strong magnets. Artificial magnets. The pieces of iron and other magnetic materials that are made to acquire properties of natural magnets are called artificial magnets. Examples are bar magnets, a magnetic needle, horseshoe magnets, etc. They are regular in shape and they are strong magnets of desired strength. Shapes of magnets. Below are some of the shapes of magnets. We have U-shaped magnets, we have a bar magnet, we have a ring magnet, we have horseshoe magnet, and other shapes of magnets. Permanent magnets. Permanent magnets, they retain their magnetic properties forever or for a very long time. Temporal magnets, they retain their magnetic properties for a short time. Permanent and temporal magnets. Permanent magnets. They are magnets that retain their magnetism once magnetized. Magnets made from ferromagnetic materials such as iron, nickel, cobalt, some alloys of rare metals, and some naturally occurring minerals such as lodestone are permanent magnets. Temporal magnets. They are magnets that lose their magnetism within a short time. They perform like permanent magnets when in the presence of a magnetic field. Example is an electromagnet. Differences between a permanent magnet and a temporal magnet. Permanent magnet, they do not lose magnetism easily. Temporal magnets, they lose magnetism when current is switched off. 2. Permanent magnets, they are made of steel. Temporal magnets, they are made of soft iron. 3. Permanent magnets, they do not depend on electric current for its magnetic force. Temporal magnets, they are magnetized when the direct current is flowing in the solenoid. Uses of permanent magnets. Magnets are used in construction of 1. Compass needle for land, sea, and air navigations. 2. Computer storage memory pen drives, hard disks, cassette, etc. 3. ATM and security or electronic cards. 4. Magnetic ink is used in banks to sort checks by a magnetic machine. 5. Refrigerator doors to keep them completely closed. 6. MRI, that's magnetic resonance imaging, for diagnostic and treatment purposes. And 7. Speakers, microphones used in phones, audio recorders, and etc. Basic properties of magnets. We are going to look at the properties or characteristics that differentiate magnets from other materials of the same dimensions. Although they may all be the same metals, the same color, but magnet will exhibit some properties that will make it different from other materials. And what are these properties? We are going to look at their attractive property, directive property, law of magnetic poles, repulsion being the surest test for magnetism, magnetic induction. Magnetic poles exist in pairs or dipoles and monopoles of magnets, and magnetic force also obeys the inverse square law. Attractive property of magnet. A magnet can attract small pieces of iron towards it. There's a bar magnet brought near iron filings, and these iron filings have been attracted by the magnet. This is a horseshoe magnet being brought close to the iron filings, and you see that they have been attracted. Not every material that have the ability to attract other materials towards is like what we see. This bar magnet, and it has attracted iron filings at its extreme ends. So this property being exhibited by a magnet is referred to as attractive property of a magnet. Attractive property. A magnet attracts magnetic substances such as iron, cobalt, nickel, etc. The two places in a magnet where attracting power is maximum is called magnetic poles. Directive property. A freely suspended magnet points in north-south direction. The end of magnet which points towards the north is called north-seeking pole. North-seeking pole. The end of the magnet that points towards south is also called south-seeking pole. So you place a compass needle, and you see that one end is pointing north and one is pointing south. And the one end pointing the south is called south-seeking pole, or simply south pole. Directive property. When a magnet is freely suspended or pivoted freely, it aligns itself in the geographical north-south direction. The pole that... Hello students, we are going to look at other properties of magnets. We look at their attractive property, their directive property, the ability to induce magnetism in other materials. And this is what we are going to study this afternoon. So bear with me. Attractive and repulsive property of a magnet. Law of magnetic poles. This law states that like magnetic poles repel and unlike magnetic poles attract each other. When a north pole of a magnet is brought near another north pole of a magnet freely suspended, the poles are found to repel each other. Two south poles also repel each other. In contrast, north poles and south poles always attract each other. This action can be described by the law of magnetic poles. Magnetic poles exist in pairs. Magnetic poles always exist in pairs. If you try to isolate the two poles of a magnet from each other by breaking the magnet in the middle, each broken part is found to be a magnet with north and south poles at its ends. If you break these parts further, each part again is found to be a magnet. So unlike electric charges, magnetic monopoles do not exist. Every magnet exists as a dipole. Magnetic poles exist in pairs. If you break a magnet into two pieces, we get two similar dipole magnets. That is, isolated magnetic poles or monopoles do not exist, although research is still ongoing to determine if monopoles can exist. Another property of magnets is magnetic induction. In magnetic induction, a magnet induces magnetism in a magnetic material placed near it. So in the demonstration above, you see that we have a magnetic material being dipped in magnetic substances and nothing happened. When a magnet is brought near to a magnetic material, it induces magnetism in the magnetic material, and that material can further attract other magnetic materials. When the source is removed, that is, the permanent magnet is removed, the body ceases to be a magnet. So now you cannot attract them further. But when you bring the magnet close to it again, then it acquires that magnetic property and it can now attract pieces of nails or iron filings. This property is called magnetic induction. A magnet induces magnetism in a magnetic material placed near it. This phenomena is called magnetic induction. When north pole of a strong magnet is placed close to a soft iron bar, the closer end of the bar becomes south pole and the further end north pole. As a result, the magnet attracts the iron bar. Induction precedes attraction. Test of magnetism. In testing to certify either a material is a magnet or not, repulsion is the surest test. This is because attraction can take place between opposite poles of magnets or between a magnet and a magnetic substance. When a pole of a magnet repels the end of another material, then the other material is a magnet. Magnetic force or base inverse square law. This law states that the force of attraction or repulsion between two magnetic poles is directly proportional to their magnetic pole strength and inversely proportional to the square of the distance between them. Magnetic field. Magnetic field is an area around a magnet where magnetic force can be experienced or felt. This can be demonstrated by spreading iron filings on a sheet of white paper or any other paper. You spread iron filings on a sheet of paper. Then, when you spread the iron filing on a sheet of paper, you place a bar magnet on the sheet of paper. The next thing you are supposed to do is to shake the magnet, which is on the piece of paper, in the presence of the iron filings. What you see is that some of the iron filings have rearranged themselves because they have experienced some force. So this area around the magnet where magnetic force has been experienced is called magnetic field. Magnetic field. Magnetic field is defined as the space around the magnet within which its influence can be felt or experienced. Magnetic field is represented by magnetic lines of force or magnetic field lines. We have two main classes of magnetic fields. These are uniform magnetic field and non-uniform magnetic field. Uniform magnetic field. A uniform magnetic field is one where the strength of the magnetic field is the same at all points of the field. In a uniform magnetic field, all the magnetic lines of force are parallel to each other or parallel to one another. Non-uniform magnetic field. In non-uniform magnetic field, the strength of magnetic field is not the same at all points of the field, and also the magnetic lines of force are not parallel to each other. Magnetic lines of force. Faraday introduced the concept of magnetic field lines. Magnetic line of force is the path along which a free north pole will move in the magnetic field. Magnetic field line is the imaginary path along which an isolated path. Magnetic field lines of various shapes of magnets. We have the magnetic field lines around the bar magnet, magnetic field lines around a horseshoe magnet, that of the electromagnetic field. We have a magnetic field lines around two unlike poles, and we have magnetic field lines around like poles. We have to take note of the directions of the magnetic field lines because they usually ask in exams. Magnetic compass. The magnetic field around a magnet can be traced with the help of a magnetic compass needle. It consists of a small and light magnetic needle pivoted at the center of a small circular brass case provided with a glass top. The north pole of the magnetic needle is generally painted red or black. Plotting a magnetic field lines of a bar magnet. The items needed are pencil, magnetic compass, and the bar magnet. You place the bar magnet on a sheet of paper, then you draw outline of the bar magnet using a pencil. You place a compass near the north pole and you mark the north pole with a pencil dot. You place the south pole at where you mark the north pole and you now indicate the position of the north pole with pencil dot. You continuously do this around the bar magnet. You join all these dots with a smooth curve. After that, you show the arrow of the direction of the north pole. You place the compass around the north pole again in different position and you repeat this process and you join the dots with a smooth curve. You do it one side of the magnet and the other side of the magnet with these dots with a smooth curve. And in this process, the magnetic field lines around the bar magnet has been done. In plotting the magnetic field of a bar magnet, the magnet is placed north-south on the white paper. The compass needle is placed near the north pole. The position of the two ends, south and north pole of the needle, are marked by pencil dots on the paper. The needle is now displaced to the new position so that its south pole exactly comes over the mark previously made against the north pole. And again, the new position of the north pole is marked. The process is repeated till south pole is reached. The various dots are joined together by a smooth curve which gives a line of force. Similarly, other lines of force are drawn. A complete pattern of the magnetic field around a bar magnet is drawn. Questions for Lesson 1. Describe 4 properties of magnets. 2. State 2 factors that causes magnetism. 3. Write 3 shapes of magnets. 4. Define magnetic field. 5. Describe how magnetic lines of force are plotted. This brings us to the end of Lesson 1.